The Inorganic Compounds podcast. In this podcast, we'll learn to name inorganic compounds and identify different types of inorganic compounds. So before you can name an inorganic compound, you need to be able to identify what type of compounds they are, because the naming varies for different types of compounds. So for the ease of naming, we have classified compounds as ionic compounds, molecular compounds, and acids. Ionic compounds are formed by a metal losing an electron forming cation and a non-metal gaining that electron forming an ion, and then there is force of attraction between them, which is called an ionic bond. These are ionic compounds. And ionic compounds are characterized by the presence of a metal cation in it. This metal cation can be bonded to a non-metal, monatomic ion, or a polyatomic ion. And we will go over each of those later in the podcast so you can differentiate between the two. Ionic compounds are generally solids, and these are many examples of ionic compounds around you. All salts, common salts, potassium sulfate, etc. are part of a type of ionic compounds. Molecular compounds are characterized by the absence of a metal cation in it. Molecular compounds are made up exclusively of non-metals. They are generally liquids and solids, and these are some of the examples. The gases and the liquids around you are generally molecular compounds. The acids start with an H, and they are present as gases or aqueous solution, and these are many examples of acids here. The most common acid that you probably use for cooking, etc. in your food is acetic acid, or diluted acetic acid is vinegar. Now I know you've seen this periodic table a lot of times and you are pretty clear about where different elements are, but I just wanted to reiterate here that the metals are to the left side of the periodic table and to the right are the non-metals. The first two groups, group 1 and group 2, they form cations that show only one valency or charge, while the transition metals that are in the middle, shown in yellow, they show variable valency cations, meaning they form cations with more than one charge. How do you know if chromium here will form +1, +2, +2, +3, +3, +4? Well, there is a list of common valencies for these transition metal cations at the end of the podcast for your reference. But at this point, it's important for you to recognize that the first two group metal cations show only one valency. Group 1 forms +1 cations, group 2 forms +2 cations, while the transition metals in between form variable valency cation. Moving on to naming of ionic compounds. To name an ionic compound, you name the cation first, and then you name the anion. Anion is always named the same way, whether your cation comes from group 1 or 2 or the transition metals. To name an anion, if it is monoatomic, such as chloride, sulfide, nitride, you take the element name and end it in "ide", and the charge can be determined by looking at periodic table, and group 7 forms -1, group 6 forms -2, or 16 forms -2, and group 15 forms -3. Polyatomic ions just are named as they are, like carbonate, CO3 2-, phosphate, PO4 3-, and there is a list of common polyatomic ions for your reference at the end of this podcast as well. Now, how do you name the cation? If the cation comes from group 1 or 2, you name it just like its element, and it's simple. For example, in NaCl, Na comes from group 1, so you name it as sodium. And then, because this is a monoatomic anion, you name it as chlorine, but ending in "ide", so chloride. That's how you name it. But if the cation comes from transition metal, then you have two ways of expressing the charge on this cation. Old way, you end the lower of the two charges in us and the higher of the two charges in ik. For example, Cu plus 1, Cu plus 2. Cu plus 1 will be called cuprous and Cu2 plus will be called cupric. Similarly, Fe2 plus is called ferrous and Fe3 plus is called ferric. That is old way of naming it. In stock way of naming it, you simply write the element name such as copper and within parentheses you write the charge 1 or copper 2 or iron 2, iron 3. And on the side, I just wanted to tell you a little joke. Do you think you can name this compound? This is all Fe2 pluses. Yes, you're right. This is called a ferrous Vl. All right, let's move on to the next slide and learn. Now practice naming ionic compounds. So when a formula of a compound is given to me, first thing I look at is its cation. You know, sodium comes from alkali metal group. It shows only one valency or charge. Hence we name it as its element sodium. And this is a polyatomic ion, and when you memorize the list, you'll know it is named as sulfate, so we'll call it sodium sulfate. This one is potassium chlorate. And again, you will know this polyatomic ion from the list. Even though this might look like there are two separate things in it, that ClO4 minus is one polyatomic ion. So this compound actually has only two parts to it, a positive cation and a negative polyatomic anion. PBS. This is not the news channel or the TV station, but PBS stands for lead. But the moment you write lead, you know that this comes from transition metals. So you need to determine charge on lead. Is it 2 plus or 4 plus? What you do is you know overall charge on lead sulfide is 0. So sulfur forms 2 minus. If this is 2 minus, then lead's charge should be plus 2. Hence, you know this is lead 2 sulfide or plumbous sulfide. Similarly, this one is cupric nitrate or copper 2 nitrate. Just a quick recap that you must put the charge if the cation forms a variable valency, and if it comes from group 1 or 2, then you do not put a charge to specify its valency. So that's ionic compounds. Moving on to how do you write the formula of an ionic compound given the name. The very basis of crisscross method for writing the formula given the name is the overall charge on an ionic compound is 0. So what you do is you write then the formula of the cation. Sodium is Na with a +1 charge, sulfide is S with a 2 minus, and you crisscross it. You bring the 2 next to Na and 1 next to S. And we don't write ones in chem, so its formula is Na2S. This is called crisscross method for writing the formula of an ionic compound. Now, potassium nitrate. You know potassium is 1 plus and nitrate is NO3 minus. You crisscross it. The formula is KNO3. Ferrous sulfate. So you know it is Fe2 plus. Sulfate is SO4 2 minus. You crisscross them and it is FeSO4. Well, you might ask, why not Fe2SO4 twice? Ionic formula for a compound, which is called formula unit, it shows the simplest whole number ratio, because this whole thing can be divided by 2 to simplify it, and then to write its formula it is FeSO4. Ionic compounds formula is written in smallest whole number ratios. Ammonium carbonate will be NH4 twice CO3. Cupric nitride, Cu3 and 2. Let's move on now to naming molecular compounds. If you recall, molecular compounds were characterized by the absence of a metal cation in it. There are two ways of naming molecular compounds. Prefix way, where the number of atoms of each element is specified by using a prefix, di, tri, mono, tetra, penta, and so on. For example, N2O5 will be named as dinitrogen pentoxide. We don't put two vowels, so we write pentoxide rather than pentaoxide. Other thing to note here is we do not use the prefix mono before the first element. So CO2 is carbon dioxide, not monocarbon dioxide. It's just a convention that we use, so just keep a note of that. The other way of naming molecular compounds is using Stockway, where the oxidation state of the first element is calculated and written as Roman numeral within parentheses after the name of the first element. For example, N2O5. Now, to get the oxidation number of nitrogen, you know oxygen forms -2. Its oxidation number is -2. Multiply by 5, and 2 times X plus 5 times -2 is equal to 0. You know overall charge on N2O5 is 0. So the oxidation state of nitrogen in N2O5 is 5. On a side comment, the oxidation state may vary with different compounds. Nitrogen does not have the same oxidation state in N2O5 as in NO2. It varies. In N2O5, oxidation number of nitrogen is 5. So we name it as nitrogen 5 in Roman numeral within parentheses oxide. Moving on to naming of acids. To name an acid, first we need to know what type of acid it is. There are two types of acid. Acids that contain oxygen in their formula, and they are called as oxyacids. And acids that do not contain oxygen. For example, HCl, HF, etc. To name an oxyacid, meaning an acid that contains oxygen in their formula, you need to look at the name of the anion that makes up an acid. If the anion ends in 8, then the acid's ending is ic acid. And if the anion ends in ite, then the acid ending is us acid. For example, HClO4 is made up of H plus and ClO4 minus. H plus is the hydrogen ion, and ClO4 minus, if you recall its name, is a polyatomic anion. It is perchlorate. So because it ends in 8, we have ic acid ending for its acid name, so we'll call it perchloric acid. We do not use prefix hydro in oxyacids. HClO3 is named chloric acid because its anion is chlorate, hence ic acid. If you have an acid that does not have oxygen, then you use the word hydro. For example, HCl is hydrochloric acid, HF is hydrofluoric acid, and so on. Now, naming complex compounds. What are complex compounds? Complex compounds are complex-looking compounds or coordination compounds. For example, something like CuNH3,4Cl2. This whole compound is called a coordination compound. And it is made up of a cation and an anion. Coordination compounds are ionic compounds, and they are always soluble in water. And this is made up of two parts, cation and anion. Its anion is a monatomic anion, but the cation is complex cation, where you have some small groups called ligands attached to a transition metal cation. To name these, you name the ligands first, followed by the transition metal cation name as its element. Within parentheses, you write the charge of the transition metal cation, followed by the name of anion ending in ite. So naming of complexes is not very different from ionic compounds, but you have to make room for including the ligands in these compounds. For details on the naming of ligands and what are different transition metal cations, you can go back to chapter 2 in this iBook. Otherwise, this is just a very short, concise summary of naming complexes. I don't want to take too much space here. The way we'll name this compound is we'll start with the ligand. So we know there's a 4, so we call it tetra. NH3 ligand is called amine. H2O is called aqua. NO2 is called nitro. Cl is called chloro, and so on. So this is tetraamine copper 2 chloride. How did we know the charge on copper was 2? We know that amine's charge is 0, ammonia is neutral. X plus minus 2 is equal to 0. So X's value should be plus 2. And we know each chloride has minus 1 charge. So there are 2. That's why this minus 2. So its name will be tetraamine copper 2 chloride. And that's a very short summary of naming complexes. Now naming of hydrates. Hydrates are ionic compounds which have loosely bound water molecules attached to them. An example of a hydrated compound is copper sulfate pentahydrate, where to an ionic compound you have loosely attached water molecules. To name an hydrate, you will name it exactly like an ionic compound, but then you will use a prefix to show the number of water molecules that are attached to that ionic compound. For example, cupric sulfate pentahydrate or copper 2 sulfate pentahydrate. Moving on, this is the chart for commonly used variable valency cations. There are many more, and there are many lists available on the net that you can use as reference, but these are the most common lists. So if you see here, copper's name is either cuprous or cupric, and as an atom it's Cu, but it forms plus 1 charge as cuprous and plus 2 as cupric. And this is a list of common polyatomic ions for your reference as well. Hopefully you enjoyed and learned naming from this podcast. Thank you for listening.